Alrighty. All right, ninth grade. Let's take a look at today's lesson, Unit 2, dash 10, meaning the 10th lesson, distance from a point to a line. Okay, to do now, let's go ahead and go through this now. Go ahead and take about 2 to 3 minutes, or however long it takes you to complete, and then I will show you how to do it here momentarily. So I've given you a bit of a hint on here. You want to find an equation of line passing through this point, right, negative 6, comma 1, that is parallel to this equation here. We're going to use this point slope form. Reason being is because if something's parallel, we know automatically they have the same slope. That's really the only part I care about this equation, right? The rest is really going to come from negative 6, comma 1 and this right here. So go ahead and plug it into your, we'll say y1 is 1, of course. We'll go ahead and do a slope. Okay, we know it's parallel, which means the slopes are equal. All right, so it should be equal to negative 2/3, which is my m right here, times x minus x1. In this case is negative 6. Remember, this first minus is part of the formula. This, of course, would then become like x plus 6. Okay, so that goes away. After we distribute, and I'll go ahead at the same time and add this positive 1 over here at the end, and we can go ahead and just add it to the right side of the equation momentarily. Simplifying some more, I would distribute this negative 2/3 to everything inside the parentheses. Okay, so negative 2/3 x minus, right, because it's negative times a positive equals a negative. I would get negative 12 over 3, okay, or simply 4, right? 12 divided by 3 is 4. So, and then, of course, I have a plus 1 over here. We'll go ahead and combine those terms. Sum of the y equals negative 2/3 x minus 4 plus 1. So this would then be minus 3 or negative 3, okay? So that's what you should have looked like. Let's go on. All right, again, today we're going to be talking about a distance from a point. Imagine that you walk out of H-E-B. You are a point in the parking lot. You spot your car from afar and say, that's where I need to be to put my groceries away. Once you do that, you would never just start walking in zigzags around that parking lot to get to your car. It's a point A to point B straight line, right? So we're going to go ahead and think that along that same mentality, right, when we approach today's topic. So when we do a distance from a point to a line, right, we're saying graph the line y equals 3 and plot the point 3, comma 6. So let's go ahead and take this one piece at a time. All right, so the line that is y equals 3 is a horizontal line, right? It should look like this, okay? So this is y equals 3. Okay, the point 3, comma 6, I'll go ahead and plot that over here. I'll plot that in red. So 3, comma 6 is right there. Okay, so that's 3, comma 6. All right. Now, what is the shortest distance between the point and the line? Well, duh, it's just this one right here, right? I wouldn't go, oh, I'm going to go over here and then come over here. And no, of course not, right? Or I wouldn't go this way or this way. The only one, the shortest distance is from here to here. Notice the kind of angle that is being created here, right? So to find the shortest distance between the point and the line, you must find the perpendicular distance, right? The perpendicular distance between both of them. So this green line that extends down from this red point would create a 90-degree angle with the blue line y equals 3. Okay? So remember, shortest distance is what we're looking for, straight lines. Okay, let's move forward. Okay, so I've given you a step-by-step process here, 1, 2, 3, and 4, on how to approach these problems the best. So here it says find the distance between point 1, 0, okay, and line y equals 2x plus 3. So let's go ahead and graph the line and the point, step 1. So let's go ahead and take that point. So it's 1, comma 0. It finds itself right around there, okay? And then y equals 2x plus 3. We're going to start at the y-intercept of 3 because that's what we're told. We know this is a positive slope of 2 over 1, so it should be up 2 over 1, right? That's the next one over there. I'll go down 2 and over 1. That's still positive, down 2 over 1. I'm just making points here that I can go ahead and draw this line with here. So my line would look like that. Forgive me if it's not the straightest. So next, find the equation of the line perpendicular to the given line through the given point. Again, the only thing I care about with y equals 2x plus 3, this equation, is its slope. Right? Its slope is so necessary because to find the perpendicular, we know that it's going to be the opposite reciprocal. So if this guy has a slope of 2, let's say, right, that means then the slope of this perpendicular one will then be negative 1 over 2. Remember, it's not only the reciprocal, you're also changing the sign. It went from positive to negative. So we're going to go ahead and write the equation now. Okay, so we know that we have 1 point, so I'll go ahead and do y. And I'm going to use point slope form again. So y minus y1. Again, we're using this one from down here, right? From the do now. Excuse me, this one right here. Okay, that's point slope form, just in case you forgot. Okay, so let's go ahead and take y minus y1, in this case is 0, right? We're told a point of 0. We're looking right here at this point right here. Okay, equals a slope. Well, we just took care of that. We said it's negative 1/2. Okay, the negative 1/2 times x minus x1, in this case is 1. Okay, let's go distribute a little bit. I get 1/2 negative 1/2 x. Negative 1/2 x when I distribute. And then negative times a negative is a positive 1/2. And I am done with that part. We have been asked to give the line that is perpendicular. Okay, so let's go ahead and take step number 3. Find the intersection between the point and the two lines. So if I were to draw let's say this red line right here, right? Sorry, that's not very straight. If I were going to draw this red line right here, well, that point right there, okay, that point right there that this lines intersect, right? The intersection point would be negative 1, 1. Okay, so this is so important because remember, this point over here is 0, 1. Excuse me, 1, 0. So 1, 0. All right. Now I'm going to find the intersection between the point, between the two lines. Again, that's negative 1, 1 in red. And now the big deal behind all of this, we did all of this just to find this green distance right here. Remember, it would form a 90-degree or perpendicular relationship between the two. Okay, so let's go ahead and use the distance formula now, right? This is from Unit 1. So it is this long thing here which says x2 minus x1 squared plus y2 minus y1, and we'll square that. So plugging on the pieces, we know, I'm going to go ahead and make this first point over here. I'll make this my y2 and my x2, and this will be my x1 and my y2. Okay, so just plugging in to the pieces we know here. Okay, so once I put in the pieces, substitute the values for the parts of the distance formula. I would say 1 minus a negative 1 is like saying 1 plus 1, or 2 squared. 2 squared, of course, is 4, because 2 times 2 is 4. Plus 0 minus 1 is negative 1 squared. Negative 1 times negative 1 is a positive 1. Okay, so then I would do 4 plus 1, and this is going to be my distance. Don't forget that we're doing the distance here, guys. So this is a distance, right? So the distance then between this blue dot right here and this red dot right here, these 2 points, is this green line that we created. Okay, so the distance, the final distance here, would be the square root of 5, which is like 2 point something. And we'd be done. All right, let's move on. Okay, so let's go ahead and we're going to go through this 4-step process a few more times. Let's take some independent practice now. All right, so find the distance between point 1, negative 5, and the line y equals negative x minus 2. So first step here is graph the line and the point. So 1, negative 5 is right here. Okay, so that's like 1, negative 5. And the line starts at negative 2, and I'll do the line at negative 2. Okay, we see it is a negative slope, or a slope of negative 1. So it should look like this. I'm just making some dots here, some points, so I can trace this line here momentarily. Okay, so my line should look something like this. Okay, it's not the most beautiful line, but it'll do for the time being. All right, this is y equals negative x minus 2. Remember, the slope on this line here is negative 1. Okay, I want to really point that out, because in a little bit we're going to have to switch that up a bit. Okay, so moving on here. Step 2, find the equation of the line perpendicular to the line through the given point. Okay, so let's go ahead and look at that now. Again, I need a slope. I'm going to change it here to red. So my slope in this situation will be a positive 1, right? The opposite reciprocal of negative 1 is positive 1. The equation then would have to carry this point here of 1, negative 5 Okay, so let's do some point slope form. So 1, y minus y1, or in this case we said was negative 5. So y minus a negative 5 equals my slope, which is positive 1, x minus x1, in this case is 1. Okay, so now we just got to do a little distribution and some simplifying here. We would get y plus 5 equals, I distribute the 1, x minus 1. Let's go ahead and take this 5 to the other side, so minus 5 both sides, minus 5 both sides. And now I'm left with y equals x minus 6. Okay, and that would be that. Okay, so this line, if I were to plot it, right, would look something like this. And that makes sense. That's a perpendicular intersection. Okay, so let's not get too ahead of ourselves here. Find the intersection between, step 3, find the intersection between the two lines. Okay, so this intersection here is going to be this point right here. So when I draw that there, this little red dot here, this little red point, that's the intersection. That's where they meet. And the meeting point is a 90-degree angle or a perpendicular relationship. Okay, so now we have found the intersection point. Again, the intersection point is this red point here, and this point would be 2 comma negative 4. So 2 comma negative 4. Now, look at what I have here. I have this point, I have this point. Last step is find the distance between the 2 points. I'm going to go ahead and start up here, just so it takes a little more room. So the distance formula, again, is, and I'll go ahead and give it to you here, is x2 minus x1, square all of that, plus y2 minus y1, and square all of that. Okay, so let's go ahead and we'll make this, it doesn't matter which one you really do, but we'll do this as our x1 and our y1, and this will be our x2 and our y2. Let's go ahead and put those pieces in. Okay, so once I've substituted my values in, I would get 1 minus 2, square that, plus negative 5 minus a negative 4, and square that. Okay, when I simplify some more, it should look like this. Okay, so when I do 1 minus 2 squared, I get, out of that, we get 1. Negative 5 minus a negative 4 is like, say, negative 5 plus 4, which would be negative 1, and negative 1 times negative 1, or otherwise negative 1 squared would give me also positive 1. I would add these two values, and I would be left with d equals the square root of 2. Okay? So important that you understand that this is the value of that little green line. That green line being the distance from the point, the blue point, to the red point, or to the blue line. All right, let's do a few more. So we're going to move a little quicker here. We're going to find the distance between the point and 3.5 and negative 2, and the line y equals 1/4 x plus 4. First, step 1, graph the line and the point. Okay, so step 1, I've graphed the line and the point. Step 2, find the equation. Go ahead and push pause and try to do it yourself on this one first. Again, you should have used point slope form here. I have taken a perpendicular, that's what this little red upside down T looks like. M equals negative 4. So the perpendicular slope is negative 4 because it is the opposite reciprocal of this slope here, right? Then I would just put into the point slope formula and simplify some more. I would finally simplify over here, subtracting 2 both sides, and I would be left with y equals negative 4x plus 12. Okay, to find the intersection between the two lines, okay, I would have something like this, right, and that would be a 90-degree. Okay, that intersecting point would be 4, so this point right here would be 4, comma, excuse me, it would be 0, comma 4, 0, comma 4, okay. So I have found 0, comma 4. That's what step 3 asked for. And then finally step 4. Okay, step 4 is to find the distance. We're going to use the distance formula, and I'll just come right up here with it again because it does take a little bit of writing. Okay, so x square, set myself for success. I'll make the first, so I'll go ahead and do this as x1, y1, and I'll do this as x2, y2, plug into my distance formula here and here. Okay, And so my final simplifying of this problem looks like the distance is equal to the square root of 48.25. Okay, let's move on. You're going to try the next ones. Okay, so go ahead and take a few minutes here to work this one out. Push pause, please, and at 15 minutes, 25, I will have a response for you. Okay, so you can probably see where I went up until this point. I'm going to change it up a bit here. What I want to do, instead of just relying solely on a graph, okay, I want to go ahead and set this up a little more algebraically, right? So I have the original equation there. I also have my new equation that I figured out in step 2. Okay, in order to find out where these two, the intersection point between these two lines, I will set them equal to each other and then solve for x. So we have set both equations equal to each other and x equals 2. Knowing that, I'm going to go ahead and plug that 2 value right into this equation, which we found out, which would be 2 times what we know x is equal to 2. We just found that out, minus 2. Okay, so y equals 2 as well. Okay, so what does this tell us? This basically tells us that our xy coordinate for where they meet, I'll go ahead and do this in this orange color, right, is going to be 2, 2. Well, that makes sense because look at that right there. That's where they meet, right? So if I were to draw this gold or orange line, that's the point of intersection. And I can find that out algebraically by setting both equations equal to each other, solving for x, and then using that x value to plug into this equation, which I found in step 2 here, right, in order to solve for the y value. So now I have a point of intersection. And at this point, then, I have 2 points. I have this one here, and I have the original that was given here. Well, I'm just going to use the distance formula in this next step, and I'm going to do a little more shortcuts on here, okay, to solve for that. And so I would find out that my distance, what I've been trying to find this entire time, is d equals the square root of 20, or roughly about, let's see, this is roughly about 4.47, let's say. Okay, so either one of those answers would work. All right, last one. Okay, go ahead and try to work this out, and I'm going to go ahead and the next slide, or the next part here, will be a picture of what your answers should look like. All right, so let's go ahead and once you have done your work, try to compare it to see if it looks something like this here. Okay, this complete imperative shouldn't be there. Let me erase that part there. Okay, this here doesn't need to be there. This is actually going to be the very next slide, which is, in fact, you can push pause if you need to on this, which is, of course, your exit ticket. Okay, so you're going to go ahead and do this. Do not forget, this needs to be, do this, right? You're going to do in Pear Deck. I know you're doing all this in Pear Deck, but this is the one slide I'm going to check to make sure that you understood today's lesson. Okay, this is what your grade will be on. It is the exit ticket, okay? Any questions, please hit me up through the Teams chat. It seems to be working best for most. If you need to hit me up on Remind, that's fine as well. Otherwise, have a fantastic day, and good luck.